Time whenever I do a video, I wanted to make sure it was a little bit shorter than the last one, and this is just going to define the difference between exponential growth and decay. Basically, for exponential growth, the base, and again we're referring to our parent function for exponentials, and just to make it even more simpler in that case, a times b to the x power. If the base is larger than 1, it's typically going to give us exponential growth, such as 2 to the x power, if my stylus works, or 3 over 2. All of that, I'm putting parentheses around it, to the, even if it was positive 7x power, or whatever the case is, then that will give us exponential growth. If the base is typically a fraction or decimal between 0 and 1, it's exponential decay, such as 3 over 4 to the x power. But this is where we have to be careful, because if I take this exponent, like say if I take this exponent here, and I make it negative, then it's no longer decay. They sort of undo one another, and now it becomes growth. So we'll see that with some of the examples below. And I, again, am making this shorter, and I'm going to skip around, talking about probably numbers 1 through 8, and then going down to 15, 16, and 17. For number 1, who cares about the 4? That has nothing to do with it being growth or decay. 3 over 8 is between 0 and 1. The exponent's positive. Bing, it's decay. For number 2, don't care about the 10. The base is 3. Exponent is positive. It's growth. For number 3, we see that our base is 7. We're like, okay, that's growth. It's bigger than 1. However, the negative exponent is going to flip 7 into a fraction. Therefore, it's opposite. It is decay. Number 4, our base is 7. Our exponent's positive. Growth. For number 5, base is a fraction between 0 and 1, but we have a negative exponent, so rather than being decay, it's going to flip and now be growth. Hopefully you're starting to get the gist. For number 6, our base is larger than 1. Yes, it is a fraction, but that fraction is larger than 1. Positive exponent, growth. So again, this base here is greater than 1. For number 7, that base is between 0 and 1. Exponent's positive, decay. For number 8, the base is between 0 and 1. We typically think decay, but because there's a negative exponent, it's going to flip it and make it growth. So hopefully you have a better understanding of the differences between exponential growth and decay. And then what I'd like to do is go through some of the examples at the bottom. So bear with me as I try to erase what I wrote earlier. For number 15, our exponential growth model is typically, it depends on the variables, but y is equal to, and let me pick a bigger pen because you can barely see that, y is equal to, looks like exponential growth, the original amount, parentheses, 1, instead of a plus, like for growth, we make it a minus. The rate, and the rate should be a decimal, all to the t power, the amount of time. The only difference between growth and decay is that minus versus a plus. Everything else stays the same. With the graphing, for 1819, I told you in Odyssey where you don't have to necessarily post the graphs, but you can use decimals to help you, or just use the XY table. And that's pretty much good to go for now. For number 15, it says the original amount was $780. You're looking at the value of the speaker if it's decreasing by 5%. Again, just to recall, to get a percent into a decimal, you need to divide by 100. So I'm going to take 780, and it says V instead of Y, so V is equal to our original amount, 780. I'm going to pop the parentheses, and I'm going to put 1 minus, hopefully you know 5% is 0.05. All to the t power. That's okay, but to get the model to actually be typically accurate, what we do is you put v is equal to, and let me zoom in so that way I can actually write better, 780, and we're actually going to subtract, so this would be 0.95 to the t power, and that's it. I'm going to do the next one, same way, but I'm going to do the subtracting part mentally. You start with 340 milligrams of caffeine, and you're looking at the amount of caffeine C in your system if it is decreasing by 12% each hour. So originally you had 340 milligrams you drank with your coffee. When you do this, you're going to take 1 minus 0.12. How did I get 0.12? Guess what? 12% is 0.12 as a decimal. You should get, 0.88, I believe? All to the t power. If it said, and this is how a lot of the questions in Odyssey were set up, if it says, to write the model, determine how much caffeine is in your system after 6 hours. Guess what? You would just plug in 6, plug it in a calculator, hit enter, it's going to give you the answer. Going to do one more at the bottom, and then hopefully, again, this is a good representation of the difference between growth and decay and seeing the exponential decay in the real world. So it's talking about that originally, so I'm going to put I. There was 400 milligrams. It is decreasing by 29%. Take 1 minus 0.29. Do it mentally. Do whatever you need to do. You should get 0.71. All to the t, in this case, not t, h. Whoops. Hopefully that was a really good representation, a quick few minute representation of all of this, and in a few days I'll do logarithms.